Good morning. My name is Garrett Snedeker. I am from FRAMATOME. I am the PSA supervisor in the United States. I'm here to talk to you guys about risk-informed engineering program. So we've got some very fun graphics from the marketing department. So it's talking about how to optimize maintenance time and cost using risk-informed engineering programs. So as a lot of you are familiar with, at plants, there's usually two sides of the coin. There's the probabilistic safety assessment, the PSA, and there's the deterministic DSA, deterministic safety evaluation analysis. Deterministic is a lot of what plants are based on. Their design basis, usually predetermined by the regulator in your country, and it is very rigid, same inputs, same outputs. Probabilistic has a much more expansive view. It looks at accidents that are beyond design basis and assigns probabilities, likelihoods, looks at multiple failures, common cause failures, human error probabilities. So there's a lot more in PSA typically. And for a lot of plants, these are very kept segregated. So they're not involved together. The risk-informed engineering program combines the two of them to help you make decisions with both of those in mind. So safety equipment at plants, as you're all very aware of, is very expensive to maintain, labor intensive, takes a lot of effort and time. Graded equipment is very expensive to purchase, and also as we're aware, there's less and less vendors available to purchase from as people tend to exit the market. And there's also concerns at a lot of plants about obsolescence. Equipment that you have at your plants that has been stopped being manufactured by the original OEM, and so now you're trying to find replacement parts, and it becomes even more difficult or more expensive to find parts that you can replace. And also, if a piece of equipment is regulated to safety, there's no risk sorting. So every piece of safety equipment has to be treated exactly the same amount of regulation, same amount of work that you have to do across the plant, no matter if it is the most important piece of equipment or maybe the least important piece of equipment. Once it's been categorized as safety, you don't have any way to get out of that categorization. And so right now, there's typically very little things you can do under the engineering analysis. And even though if you have a PSA at your plant, you might be able to look and see that some equipment is very important for safety, some equipment is not important for safety, but you're not able to use that risk sorting to be able to identify what equipment is more important for safety and what equipment is less important for safety. So what the risk-informed engineering program gives you is flexibility, which is kind of a buzzword these days in operations. Flexibility to be able to use both your PSA and your deterministic to allow you more options for doing maintenance, for doing replacement of parts. When it comes to outages, it gives you more flexibility related to your outages. It's also optimized. You're able to lower your cost using this because you can focus your costs on what actually impacts plant safety, and that is where you can spend the most time and money and effort, and you're able to reduce costs elsewhere where it doesn't impact plant safety. It also helps with efficiencies. With outages, if you're able to move things out of the outage, typically that is going to save you a lot of money. We're trying to make outages as efficient as possible, as short as possible, because the longer you're down not making power, the less money you're able to make. And right now, in the market that we're in, across the whole world, nuclear is getting squeezed with costs from other low-cost energy providers. So nuclear needs to be cost competitive, and this is a way to help optimize those costs and help you drive the costs down so that nuclear can be competitive and also can have a longer-term future, especially in the United States for a lot of plants. This is a way that they can envision staying in operation long-term because of the market and the pressures that they're seeing. ooh and ah at the graphics. I really thank you to the marketing department for doing that. For categorization, which is what the risk-informed engineering program does, it categorizes things into LSS, which is low safety significant, and HSS, which is high safety significant. So previously, where you had just either safety or non-safety, you now have 4 categories. And you're able to lower your costs on the low safety significant and focus in on the high safety significant. For Framatome, we've been doing this for a while now. We've got the most experience in the entire world doing it. On our team, we have multiple people who are the originators of this process. They wrote the documents that in the United States are used. And then we've categorized as a team over 100 systems at various plants, and over 100,000 components have been categorized into either HSS or LSS at various plants. And the plants that have those are using them to do alternative treatments, to be able to treat components that were classified as safety, but we know is low safety significant. They're able to classify those cheaper. They're able to procure parts for cheaper. They're able to focus their maintenance on the parts that are more important for safety and less on the ones that are not important for safety. So I've talked about the HSS and LSS and the safety, and we've got this great graphic here. So there's 4 different bins. On the left side, you've got your safety related. And if you can see, the top part is the high safety significant, the lower part is low safety significant. So there's 4 different bins here. There's fun graphics going on. I'm not going to try and talk that fast as it's going, but I'll see what I can do here. So risk 1 is your safety related components, and it has a high safety significant. So this is the most important to your plant safety. Current regulations that you're already doing for risk 1 continue on. You don't have to do anything additional. You keep what you're doing there. It's identified that it was determined to be safety, and it is of high safety significance. Keep doing what you're doing. Risk 3, the graphics going through, it's very fun. Risk 3 is really the area of interest. So it's safety related, but you've determined that it's low safety significant, which means the failure of a component does not impact plant safety or environmental safety either. And how you get there, I haven't really talked about the categorization process, but I'll talk through it a little bit. There's 3 different parts to it. There's a deterministic or qualitative portion of it, a PSA or probabilistic portion of it, and there's also a passive or pressure retention function that you have to look at. And to get through all of those 3 different parts is what you can categorize yourself into low safety significance. So it's a very, very thorough process. It's approved by the US NRC, so this process is approved. And for plants, they approve the program, then they're able to categorize systems as they follow the program. When you get into risk 3, you've realized, although it was categorized as safety when they built the plant, based on the analysis, it's of low safety significance. So again, failure does not impact plant safety. It does not increase core damage frequency or large early release frequency. And that is an opportunity to reduce the amount of effort you're spending on that. So for maintenance that you're doing, it doesn't need to be done to the same safety level of maintenance. The testing that you're doing can be reduced. And more importantly, if you're replacing a part, you don't need to replace it with a safety grade part. You can get industrial grade replacements. And we know in very many other industries, oil and gas, chemicals, they have parts. They don't want them to fail either, so they are making parts that are very reliable as well. And also, you're able to, in some instances, get more recent technology that isn't approved for safety-related applications that you can put in there, and it's able to reduce the costs, and in some cases, reduce the cost as much as tenfold. So a reduction of 10 in the cost to replace parts. And some of these parts can be as simple as a simple drain valve. So you're saving yourself maybe $2,000 a valve, not a lot. But also there are examples of replacing large sections of buried pipe that you have. And as plants get older, you need to replace the buried pipe. Some of that buried pipe that you can replace, an example at a US plant, they replaced one leg of buried pipe. They were able to categorize it as LSS. That replacement saved them $800,000 on just a single leg of replacing the pipe. Other opportunities you have is to not replace the pipe, but to do pipe liners or other opportunities that you can reduce costs there. Now, I've talked a lot about the safety-related side. I want to talk a little bit about the non-safety-related side. So the non-safety-related side, typically we would say, well, if it's non-safety, it doesn't impact any core damage or anything like that. But we find in risk 2 space, high safety signals are about 1% to 2% of components that were determined to be non-safety related, but do play an important role in plant safety. And so those 1% to 2% of components need to be looked at and realize these are more important than we thought, and determine if the way you're treating those components is correct or if it needs to be added onto. Typically, the add-on is not much, but it is an awareness that there might be non-safety related parts that do play an important role in plant safety. Typically, on your non-safety side, it would fall into risk 4, which is low safety significant. What we would all expect is that the non-safety related components also do not play a role in the safety significance. And from the safety related side, I didn't mention this, but risk 1, typically we've seen about 25% of components end up in risk 1, 75% end up in risk 3, and then 1% to 2% in risk 2, and then 98 to 99% end up in risk 4 space. So here's an example of a plant that we worked with. They had some needs. They were looking to reduce their O&M costs. They needed some flexibility. And the main thing was they were looking for long-term viability. So they're looking for long-term operation. They wanted to extend their license, and they're trying to figure out how they can in a very competitive market where they were located. So the risk-informed engineering solution, so we went to them and we categorized 5 systems for them just to start with, just 5 systems. When it comes to categorization, you can pick any number of systems. You can do 1 system, you can do 100 systems. You do have to do a complete system, no cherry picking of components. You need to do a complete system, but it's not limited to, you got to do all or nothing. It can be a very small scale. So they picked 5 systems to do. We categorize them by LSS and HSS, and then we look for what we call alternative treatments. And the success and the results of that. So we were able to find cost savings for them in replacement parts for valves, also replacement parts for their radiation monitoring system. It gave them flexibility. We found, just for those 5 systems, we found 700 hours of outage time that were potentials for savings there on just 5 systems and just 1 outage, 700 hours. And based on what we did, they actually contracted an additional 22 systems that we're currently working through so that they can expand the pool of components that they're able to look at and optimize both their outage and procurement related to. Make sure I'm doing good on time. So this is saving time, O&M costs, and just costs in general. The big thing here is that overall, plants are struggling to continue to operate with costs going up in a lot of different areas. And this is able to help them by reducing costs, but also gives them flexibility. So flexibility, moving things out of the outage, but also being able to move things around in time and space for them is important to them because of the market. We've got a couple more examples here that I want to talk through of other plants that have used this and been very successful. We've got a plant that's done 8 systems so far. Maintenance-wise, they've been able to save $330,000 just through ISI, in-service inspection, in-service testing changes, and then through procurement, through valves, chemical and radiation monitoring procurements, they saved $450,000. Then there's another site that's categorized 100 systems, so they went all in. Maintenance-wise, they're saving $400,000 per year, and procurement up to this point, they've saved themselves $3 million in procurements. And those procurement costs are, as you're aware, one-time costs. Those maintenance savings are ongoing savings. So it's every year they're saving that. They're spending that less every single year, year after year. Depending on how much life of your plant you got left, that could be 20 to 40 years worth of savings every single year. In the procurement space, it varies. For a lot of plants that are going for extended license renewals, they're looking at a lot of expensive replacements. Buried Piper, the example that I gave earlier, that one site that just a single run, they saved $800,000 on that. And actually, unfortunately, it was the third, I believe, buried pipe that they had replaced, and they had gotten a little late to the party on starting doing the categorization. So the first two, they weren't able to save any money, but by the third one, they were able to. So the delay there cost them a significant amount of money. Of course, by the time they got it, they were very grateful for the opportunity to be able to save a lot of money there. And these are just some examples. In the United States, there's a lot of different plants using this. Roughly, I believe at least half of them either have submitted or are currently planning to submit. We're supporting a great many of them doing this work. We're also supporting on the procurement side of the house as well with our parts department. So just kind of our tagline here, the risk-informed engineering program reduces significantly the cost and time of outages, maintenance, and long-term operation through the evaluation of safety-related equipment and the most effective alternative treatment solutions. So thank you very much for your time. I hope that you've learned something important. This is something I'm very interested in, very passionate about, in helping maintain nuclear for a very long time. I would hope that my children have an opportunity to enjoy nuclear power as well as I have. Thank you very much for your time. And I will be over here if you have questions. I'm sure there's a lot of, I left a lot of gaps because I can't explain the entire thing. So if you have questions, please feel free to come over and ask me whatever questions you have.